Okay, so let's actually start with a little poll. Who of you doesn't know what kubeflow is and how that works?
I am that ignorant, Laventa. Yeah.
Two. Okay, that's not ignore. No. It's actually, I wouldn't call it a niche technology, but it's not something everybody uses. No. So let's actually tell you something like 3 sentences about kubeflow. So I will share my screen now, and I'm just walking you through a little publication we have submitted to IEEE Open Source Conference in Chicago, but we still don't know if we got accepted. So just searching for output of the kubeflow UI. Zoom out a little. So zoom, say fit age. Okay, it's too much. Okay, so this is the part of the UI. So kubeflow comes with the UI. And what you see here is actually a visualization of a so-called run. So there's the notion of the pipeline. So if you click here on pipelines, I mean, I can show it to you in the interface later. Then you see all the stored pipelines. Pipelines can have parameters, so you can run the pipelines with different parameters. For example, grabbing a different data set or writing to a different storage or executing some different things. So you can parameterize pipelines. And the cool thing is they then end up in the runs. And you see in the list of runs whether they have been successful. And also you see all the metadata. Now you see what containers have been used. And speaking about containers, here each processing step is backed by a container. So you can create a Docker image and push it to registry, and then kubeflow will pull it. And actually each of that rectangles is a Kubernetes pod. In case you don't know what a pod is a scheduling unit in Kubernetes, which consists of at least one container, but you can have more containers per pod. This is sometimes used for initialization, so those are the so-called init containers, or there are sidecars, containers which do some pre or post processing on a network level, and each pod shares basically the same virtual network interface, just as a little reminder. And the idea is to schedule pods one after the other, or also in parallel. That's how you express your pipeline, aka workflow. And at the end, if you're lucky, then everything turns green and you're done. And then you end up with one more successful pipeline run in the run section. So that's kubeflow. So as you already heard, we need to have containers to actually create such pipeline steps.
Sorry, I missed this one question only. So this is primarily for ML. Most of the runs are they're like runs you manually trigger, or there's also this is also for scheduling for like Airflow type ETL stuff. No, it's both, I guess.
Yeah, you can do also scheduling. Yeah.
Thanks.
So you see those in the recurring runs, and you mentioned Airflow. And if I mention Airflow, I also mentioned 2 other technologies. One is called Argo and Argo workflows, and one is called Tekton. And it's interesting to notice that actually IBM created together with Red Hat the kubeflow version, which uses Tekton as the execution engine, and the stock kubeflow uses Argo. But in both cases, what kubeflow does, if you compile such a pipeline, you generate an Argo YAML or a Tekton YAML file. And the only way how then kubeflow can visualize such a pipeline, which is actually then stored and executed in Tekton, is by annotation. So all the pipeline steps in Tekton are annotated with kubeflow specific annotations, and that way kubeflow can then basically draw those graphs. By the way, it's more than okay to interrupt me. I really encourage you to interrupt me. Okay, so yeah, the thing is, it's relatively complex to create such components. We call those execution steps, we call a kubeflow pipeline components. They consist of a container image and a YAML descriptor file. I mean, it's not super complex, but actually, if you are like a Python programmer, then it's just, in my opinion, unnecessary overhead. So that's why we created this library called Claimed, which stands for Component Library for AI, Machine Learning, ETL, and Data Science, just to cover all the buzzwords. But we realized that creating the components is still something which is complicated, no? So what we actually do is we have the source code, we have a compiler called C3, and then at the moment this C3 can compile this source code into a container image and also create the corresponding KFP component YAML, so kubeflow pipeline component YAML. And the way it's actually done is we have to just follow 4 things. The first cell in the notebook is the name of the component. The second is the description. The third is all the dependencies. Then obviously you need some imports, and some linters complain if you don't put all your imports at the top. That's why they are at the top. Me personally, I don't care. Then the important part here is the interface to the component, and that's something which really is a good practice if you're also using this whole stuff outside Claimed and kubeflow, to have all the interface to your code at one central place, and you can just set it. You see here there's some information hidden. So we have here a comment. So that's actually the description of your parameter. You can extend this line up, of course, the name. And then what also is there in some of the components, you see that here we have default parameters. If you set a default parameter, then we know actually that this is an optional parameter. And also sometimes you cast to int, float, or boolean. And then we also can infer the data type. So we support
Romain, could you zoom again a little bit?
Please go ahead. Yeah, what?
Could you zoom in again a little bit?
Zoom in? Yeah, sure. Stay to 58, or we can even push it a little. Yeah, okay. So, any better?
Yeah.
Good. Okay. So, yeah, and then we can infer the data type. Now, we support string at the moment, boolean, float, and int. And just in addition, we support, so this is auto-generated code, we support command line parameters. So you can do 2 things. You can execute this notebook from the command line using IPython, or you convert it with nbconvert to Python, and then you execute it via Python. And you see here 7 and 8, that's the only code. The rest is all, let's say, meta information. So that's a super simple example, of course, but this is just a component which stores some data into S3. No? That's all it does. But with this component now you can drag and drop it. We have a user interface. I'm not sure if we have time to show it, but I can. Or you can just code it, and I show you some code how to easily create such pipelines in code. Both is possible, okay? So the component compiler then actually extracts here using, in this case for Python, a regex, extracts the interface. And the other thing, since one thing I didn't mention is, using this dependencies here, we create a container image. We install all the dependencies in the container image. We push the container image to a registry, and we create a YAML file. If I'm not finding it here, I will show it to you later. And another thing, which is quite handy and useful, is for development or for some little tasks. All the components you can also execute from the command line. So you just say claimed space and then the component name. If you want, you can put an optional version. Otherwise, it's just grabbing the latest. And then there are all the components interface, name, key value pairs. No? And that's basically just executing each component in a container runtime like Docker or Podman, and data exchange happens via Docker volumes. At the moment in the repository, we have around, I think we have 65 now, 65 open source operators. But you can actually mix and match. No, you don't have to use everything in open source. So we donated this whole stuff to the Linux Foundation, but you can use the compiler and you can create your custom private components, which you even could sell in theory, but which you don't need to open source. Okay, that's just one example. I told you about the graphical editor. If you are interested in that, we can also have a session about that one, or I show it to you later. But actually, kubeflow is often just coded in code. It's first-class citizen on OpenShift. So if you are running the Red Hat OpenShift data science platform, then you get full support from Red Hat on kubeflow. That's also a neat thing. You don't have to care about anything. If there is a problem, you can open a ticket with kubeflow. And the project is quite mature now. As you see here, there are a couple of clients which are using it, and some of those even wrote a paper with me. And here you see the project's impact. But anyway, so now let's actually have a look at some code and actually do something. So let's go to VS Code. And you see here, we have this upload to COS YAML file, which has been created by the component compiler. So you might remember we had in the first notebook cell the name of the component. In the second notebook cell, we had a description. And then we had the imports. The imports actually landed in the container image. The container image has been pushed to a registry. I'm currently in negotiation with Docker Hub because this is an open source project and I want to move all the stuff to a claimed org and not to my private node. That's something I need to do. By the way, all that stuff, if you check it in to GitHub, it's automatically built. So the containers are automatically published. And yeah, then I need just to switch the organization here. Yeah, okay. So, and then you see here the inputs and the outputs. And then the trick is here, it's then using IPython and executing the notebook and then actually passing all the parameters to the component. And the new version of the compiler, so this is an old artifact. The new version actually first of all converts the notebook to a Python script because we don't need the overhead of IPython now, and then directly executes it with Python. So now you know how to easily create components. Now I show you actually how we can create such a workflow. But before I do that, I just saw here, I'm currently here working with Levente to create this remove clouds component. And you see here it's already compatible with the compiler. So we have the first cell as name, the second is description. Then we have all the dependencies, the imports, and then we have the interface. And I just realized I have to change again the secret access key before I publish the video. Yeah, so the new version even adds a logger. This is interesting because it also goes down to the referred libraries. You see, for example, if you like on the debug level, all the stuff, the S3 FS library outputs, and it's maybe got not bad for debugging purposes. And then you see all the code now. So after that, it's all your code, and C3 doesn't care about what you code. No, it's just the header. Questions so far? Comments?
So
additions?
if we make a
Yeah.
change, let's say to this not the Python notebook, that it's going to be automatically picked up, or you need to somehow recompile, or how it's going to work?
Yeah. So if you use the open source at the moment, you just need to create a commit and a push to the repository, and the GitHub action will pick it up and create the component, and either it fails or you have a new version of the component in the repository. If we develop private ones, I think I need to double check which is the latest and greatest tool we need to use. I think it's Jenkins at the moment, the latest thing I heard. So we have to create a Jenkins workflow for actually creating. But that's something I can take care of. That's not a problem. So the only thing, I want to make it for you. You are the researchers, no? I want to make it as easy as possible. You can stay in your environment, the stuff you know. The only thing is basically just telling me what you expect as parameters, and then some magic happens, and then you have the kubeflow components ready to use in another code or in the UI. And yeah, I show it to you how to create the workflow, but I just want to see if there are other questions.
Is it trivial for like the access keys here to pipe those in via parameters? Is this a mechanism, or is it?
Yeah, there's the mechanism is called Kubernetes secret. That's also possible. So you can either provide here the secret access key directly or the name of the secret, and then you yourself, but I can obviously, if you like, create a little utility function for you. You need then to get the secret access key via the secret ID, and then you add the secret to the Kubernetes deployment. Is it clear how that works? Or?
Yeah, it's been first approximation. Yeah, it's clear.
Okay, good. Other questions? Okay, then I show you just a little code example. Let's double check where this is. This should be, is it there? No, it's not there. Let me actually, yeah, I have to go to recent. And I think it's here. Okay, so here, that is something which I haven't done yet, but what I want to do is I want to create auto-generate, so the C3 compiler, it will auto-generate classes for you that you don't need to write this import code here. No, at the moment how it works, you can load a component from a URL, and you see here it's in the repository, and the YAML which the compiler created is actually used to create a Python class. Okay, so to create such a pipeline, you have to have annotation here, and then a function, and that's basically the pipeline, and then you have steps. So let's actually go to this more easy to understand example. So each component, because I named them A, B, C, D, and so on, and you can say then B runs after A, and D runs after C, and E runs after B and D. And that's how you create actually the workflow in code. And how you set the parameters is here. So you have actually here the component, and you can pass the parameters here in that function. No? And those parameters are those. Let's go back to the source code. Those are the parameters you set here. And they are then also ending up in the YAML file. No? So you have typed parameter passing, and it will actually give you an error if the type or the name or something of the parameter doesn't work. And then here you have this step 2 after step 1. So that's actually just a little example, pulling a file from somewhere. So that's a URL getter component, and another component is run then to push the file to object store. No, just a simple example. Okay. Are there any questions, comments, additions, lanes? But since we have a little time, I will show you the graphical way of creating the components. So let's go to, I can do it the following. Docker run, let's increase the size. Run, and then what I do is, so this is Elira, which is basically a Jupyter Lab extension. And I just need to map the port. That should be it. And this has basically the extension installed. So, and by the way, this Elira editor is also part of Red Hat OpenShift Data Science, and you also get full support from Red Hat on it. You see here, if Elira is installed in Jupyter Lab, you get here those, by the way, the Python editor is also part of Elira, but that doesn't matter here. But you get those 3 launcher tiles here. And let's start with a generic pipeline editor. And let's actually create 2 notebooks. Or let's create a notebook and a Python file. Okay, we say new notebook. And we say echo test. I think I'm in the wrong. Okay, so let's double check if that works. Okay, so we have 1, and then let's create actually a Python file. And then we say also print this 2. Save. And here that's also cool because now you can run Python code against Jupyter kernel. That's also a contribution from Elira. No, you see it here. And now we go back to the editor, and let's drag and drop those 2 things on the canvas. So now it turns red. So let's have a look why it turns red. It actually says, I mean, I pushed this as a request, but it's not yet implemented. I want to have a default container image assigned, but you have to assign it here. So you are asking yourself, why am I assigning a container image to a notebook or Python script? And that's the cool thing. You can now say run. and it's not configured yet, but you can run it now as a kubeflow pipeline. So if we have time, we can configure it later together. But now let's actually create a local execution. So you should see in the console that those two notebooks, the notebook and the Python script have been processed. And you see here also the output test 2. And that way you can test your pipelines locally. And it's ignoring the container image at the moment. So we wanted to actually make sure you can run it in Docker. Then you could also run a kubeflow pipeline kind of locally on Docker without even having kubeflow. But that's in the process of being made. And let's actually try to get the pipeline running. So what I need to do is I need to get to a kubeflow cluster and create a new runtime. So you see it's all pluggable. No, we can
The only one who's lost audio?
Yeah, we lost him.
Me too. Let me ping him. Let me ping him. Oh.
Hello, can you hear me?
Now again, you were gone.
Okay, what was the last sentence?
This is like a trick question. You did this on purpose, no? Last question. I don't know. Does somebody know the last sentence? I'm sorry.
No, it was very short. Very short.
Okay.
Like
so let's rewind. Okay. So I was just creating a kubeflow configuration, no? Because you actually wanna. I closed this browser tab. That was a bad idea. But I'm lucky. I think I still have it. Yeah, perfect. Okay. I'm not sure if it works because sometimes I need to double check the versions of the client libraries and the server libraries. But the idea is the following. No, you can actually set the kubeflow pipelines endpoint here. And in our case, we need to use Tekton because our kubeflow runs on top of Tekton. It's inside our VPN, so there's no authentication at the moment. Okay. Yeah, it would take a little more time. I also need to set up cloud object storage endpoint, which I could do in theory. I mean, we have time. Let's actually try it. Just that you see how this works. Anyway, we have to change the keys again, so we can actually do that. So that's the endpoint, that's the bucket name, so you see here that you can also set a secret, but we want to use this one here. And then we use the access key. So the secret here would be just a string, no a key. And the bucket name is that one, that doesn't matter. And the endpoint is also here. Okay. So not sure if it works, but we can give it a shot. Save. And now we can hit play. And then we should see here kubeflow pipelines and the test configuration. So most likely it won't work because something is definitely messed up, but we can give it a shot. So it will actually now compile, error. It will compile this pipeline. Let's go back to this pipeline and let's open it with a normal editor. And you see here the pipeline in Elira is a JSON file. You have some unnecessary information like the coordinates or the position of the component on the canvas, like here, but the rest is quite important, what component runs after which component. And what then Elira does, it uses a compiler, like claimed, and it compiles this JSON into KFP YAML. So you see the same here. If I go back to this example, at the end of my workflow description, you see here Tekton compiler, compile, and the pipeline. This is this function here. And then it's a YAML file. And this YAML file, you can then submit to kubeflow or you can submit via API. And then it's actually, since we have it open, I can show you a little around here. So here we have the pipeline. So this is the one I've created in code. and it's actually also versioned, so you have multiple versions. And I'm not sure why it's taking so long. So let's just use a version. Each pipeline has a unique ID, which you see. And here you see the pipeline. So this hasn't been run, no? And now you can say create run. Actually, we can do it. It should work. And it pre-fills stuff for you. You can change it. And it can also, here, I don't define any parameters, but each pipeline can have parameters, as I told you, and you can here put the parameters and you click on start. And what then happens is it ends up in run. No, let's actually go into it. And you see here, those three are then run in parallel. And each one is a pod. So I can click here on the pod tab. Sorry, on the log tab. Okay, it will take some time. So this pod is actually not yet running. Now it's running, I guess. And then, yeah, this one is definitely running. You see it here. This one is completed. This is running. And those are scheduled. Okay. Now it's just running the pipeline. If you go back, you see here, this is also running now. And some of those failed. I think that's concluding most of it. I'll stop the recording. Then we have maybe a more casual discussion and see how we get. Thanks for joining. Take care. And recording is stopped now.